Find the area between two curves. Do these curves look familiar to you? They should.
Oh, yeah.
Yeah, we just did those. This says find the area of the region between the graphs of the functions. I'm going to use my graphing calculator today to show you guys the visuals instead of me drawing them. Being able to sketch functions, though, does help. If you can just sketch it on your own, that's really, really helpful. Except the hard part about sketching on your own is sometimes you might not see right away which function is on top. Which one's the upper function. So let's look at our graphing calculator. I highlighted the functions that I want to graph, and I'm going to go back to my graph. Here's the first function, the blue one, and here's the second one. Our job is to find the area between these two curves. Okay, we found the area underneath each curve. Now I want to find the area between those two curves. I think the directions 2 specified that we're going to find the area between 1 and 3. So we want this right here. That is what we're looking for. We want to find this area. So how do we do that? Very good. Half of you guys got it. When we found the area of the blue, underneath the blue curve, we found this area. If you remember, this area was bigger than the area, the red area. So if we found the area just underneath the blue curve, that's what we would find. We'd find the area, like all that area. If we found the area underneath the red curve, see, red curve would be right here. Well, look how curvy and smooth that is. Alright. This is what you would get. Now, if you had a plan, you said this. You said, I'm going to find the area under the blue curve, find the area under the red curve, and subtract the area underneath the red curve from the blue curve. And then you'll be left with what we want. So that's what we're going to do. So let's go back to that's our visual. You guys ready to attack this bad boy? So this is what we got to do. We're going to take the area. Don't write this first part because I'll have a simple way for you to write it. We're going to take the area underneath the x squared minus 4x plus 10 dx. And then we're going to subtract from that the area from 1 to 3 of 4x minus x squared. Don't write it yet. Don't write it yet. Okay, watch what happens. This is neat. Okay. Do you guys remember how we can split integrals apart? The section that we did said this is the linearity of an integral, how you can split it apart. If there's addition, you can split it apart. You guys remember that? Well, hey, if there was subtraction, you could split it apart too. So this is already split apart for us, but let's not write it to split apart. Let's combine them. So since they're under the same integral from 1 to 3, we can say x squared minus 4x plus 10, and we can subtract from that 4x minus x squared. Make sure you put parentheses though, because you're going to have to distribute that negative. Dx. Now I'm going to make sure all of this is included in my dx thing right there. And now I simplify what's inside. Simplify the integrand. So I'm going to go and distribute this negative. So that's negative 4x, and that's positive x squared. All right, how many x squareds do I have, students? 2 x squareds. Okay, there's one right there, and there's one right there. How many x's do I have? I have a negative 4x there, negative 4x there. How many x's do I have? Negative 8x. And then I have a plus 10. There you go, there you go. This will give me my answer. This will find the area underneath or between those two curves. So let's do our antiderivatives, shall we? We shall. X to the third power, and then I'm going to divide by 3. So I'm going to divide that 2 by 3. Minus 8x raised to the second power, that divide that 8 by 2. And now I'm going to go plus 10x, and I'm going to have to plug in 1 and 3. 3 first, and then we subtract it. So the last thing is plugging in at 3. So we have 2 over 3 times 3 raised to the third power minus 8. No, I'm sorry. What is 8 divided by 2? That's 4. So we have 3 raised to the second power plus 10. Hey, where's my x? That should be an x on that 10. Oopsie. Sorry. 3. Minus. Now let's plug in the 1. We plugged in the 3. Let's plug in the 1. I have a crazy parenthesis on steroids right there. We have 2 over 3. 1, raise that to the third power. We're going to go minus 4, 1 raised to the second power. And we have a plus 10 times 1. and then parentheses with steroids. Okay, on steroids. You don't matter, you don't matter, you don't matter. Okay, so we have, let's do this. -4 and 10. What's -4 and 10? 6. Okay, is that a positive 6? Yeah, it's positive 6. Positive 6 plus 2/3 is going to be 6 and 2/3. But then you have this negative out here outside the steroid parentheses. And we have 30 right here. What is 3 squared? That's 9 times 4. What's 9 times 4? -36. Oh, I need a plus sign right there. Then we have, 27. 27 times 2/3.
18.
Yeah, very nice. Let's see. 2 over 3 times 27. I'm going to put that over 1 so you guys can see. I can divide that by 3 and that by 3. I get 9. So it's 2 times 9. 2 times 9 is 18. That's a crazy question. Okay. Let's add our positives together. We get 48. That's the 18 and the 30. Let's add our negatives together. We get -42 2/3. Because 6 plus 36 is 42. Then I add that 2/3 together. What is 48 minus 42? That would be 6, right? But we can't write 6 because we have to subtract 2/3 from it. What is 6 minus 2/3? 5 and 1/3. That's your answer. Most important thing to remember, class, is that you're subtracting the upper curve minus the bottom curve. Okay? Always subtract the bottom curve from the upper curve. Whatever curve is on top, that's what is first. The one that's on bottom is the one that's second.